afternoon, everyone. My name is Julie, and together with my teammates Nick and David, we're going to present to you today our strategies so far for our health mattress project. So according to the Department of Health and Human Services, in the U.S., approximately 2.5 million patients each year suffer from bedsores. And unfortunately, around 60,000 of these patients result in they end up dying because of this. So essentially, bedridden patients lack this day-to-day movement abilities that we normally have. And this causes many health-related problems such as joint stiffening and the formation of pressure ulcers, amongst many others. And in particular, pressure ulcers form due to shear forces. In other words, the pressure of the bones against the surface, in this case, the bed, due to friction of the skin against the surface, and also the tension of blood vessels. So in order to minimize the risk of bed sores, patients need to be turned around or repositioned every 2 hours. The current clinical solution to this problem relies mainly on the caregivers to turn the patients around every 2 hours and on physical therapists to come in and move the patient's limbs and joints periodically. Now the problem with this is that the solution is not only quite physically taxing on both the caregivers and the physical therapists, but also these particular therapeutic sessions are not frequent enough and they have limited duration. So with all this in mind, our mission for this particular project is to develop a comfortable system for residential bedridden patients which seeks to reduce the risk of pressure ulcers and joint stiffening while minimizing routine caregiver effort.
So with this in mind, taking the problem into consideration and also discussion amongst ourselves and with our client, we looked at some prior work to look at how we can further develop this field. We have some low-end mattresses that we looked at as well as some high-end mattresses. The low-end ones is such as the one that was shown several weeks ago. It's just basically an air pump mattress that alternates the chambers that are filled, such that the pressure points are continuously altered. The higher end ones, which are about an order of magnitude higher in cost, they provide more safety features such as an edge to keep people from falling off, as well as some moisture control to prevent the pressure ulcers, as well as some more specific settings to that for weight and comfort. We also looked at some other technologies beyond just the mattresses. For example, we looked at some sensing capabilities using thousands of pressure sensors to figure out when, how long, and where the pressures points are applied. But these systems cost like several $1,000s, and but they're really useful in providing feedback to the caregiver and to the patient. And then as well, we're looking at more joint stiffening solutions. There's these passive systems, mechanisms that are used to move the joints, but these also cost in orders of thousands of dollars. And they also take a lot of time to set up every time that the patient is going to use them. So based on all this stuff, we were looking at trying to come up with the functional requirements for the project. And we want to create something that is that not only adds to this thing, to this field, that is safe, but also provides something that is mid-level cost, something that's not as cheap as $100, but not as expensive as $5,000. So we're looking at something between $500 and $1,000 that provides more joint actuation, but also continues to modulate the pressure points on the mattress. Some secondary features as well that we're looking at: body rotation for circulation, aesthetic, and also patient sensing if possible, focusing primarily on those three.
Yeah, the three primary strategies that we're going to discuss at a high level related to solving this problem are as follows: a pneumatic system with a grid of air bladders similar to the existing pressure mattress systems that are in the field, a sort of electromechanical body crane system, and a combination of a roller mechanism and robot arms in a sort of combinatorial system. And here's just three basic representations of those systems. So the first is an air bladder system that is composed of two semi-modular elements working in conjunction with each other. So on a typical air mattress, there are sets of two air bladders that you can alternate activation and deactivation of to alter where the body is being supported and modulate those pressure points. The concept we're looking at here would instead have a semi-modular grid of pressure point variation locations so that you can alternate the locations to provide different pressure points in the body, or provide larger motion in some subset of the bladders to help raise parts of the body specifically. So in this case, you could lift up the leg using a set of bladders that are individually addressable. Some of the risks and benefits of the system, it is a risk in that for this concept of lifting limbs, you have to be lifting from underneath with a sort of bladder, and you'd have to figure out some means of encapsulating that limb slightly so that it wouldn't roll off as you're inflating the bladder. Additionally, there is comparatively little space to innovate in this marketplace because there are a lot of existing mattress solutions. And having an individually addressable set of bladders requires a lot of actuation and control, and that would result in a complex system. It's beneficial in that the low profile of the system in its relaxed state is likely to be more comfortable. It uses entirely soft actuators, so you're less likely to hurt the person that is in the system. And there is substantial prior art that we can use for design inspiration, so that's both a risk and a benefit. The second system is a sort of overhead gantry linear rail combination where there are two rails running over the top of the bed, and each of those rails has a carriage that can move on it with a hanging cuff and cord element so that you could have a caregiver attach that to the patient and then use the actuator to move it back and forth as well as raise and lower it to generate a sort of approximation of limb motion in this system. Some disadvantages and advantages of this system: it's more setup time for the caregiver in each time because they have to go and attach these elements to the body to provide that motion. Additionally, it's encapsulating the patient, so it's potentially less comfortable and could restrict access of the caregiver to the patient. On the benefit side, there are comparatively fewer actuators conceptually to this air bladder system from the previous solution, and the motion profiles that can be generated are a little bit more diverse than just raising and lowering the limb from beneath. The last system that we looked at is, I think, kind of a creative, cool solution on one end, and the other end is just kind of a scary robot arm. So this is composed of essentially two elements. One would be to take a traditional massage roller, which is an inner rigid core and then outer rotating elements, and place that under a thin mattress pad layer between the mattress and the patient that would be addressable to roll up and down under their body to provide slight shifting as opposed to a pressure solution from air bladders. And then the second element would be attaching robot arms on the sides of the bed in addition to this linear rail subsystem to help with moving the patient's limbs. Some obvious risks of the system: if you're using all these rigid robot mechanical elements, if it malfunctions in any way, it's far more likely to injure the patient. Additionally, the passive state of the system requires that there's all this rigid stuff around them, which is likely to be less comfortable. On the advantage side, I believe the roller element is slightly more innovative, so it's a little bit more of a market space there. And there are comparatively, again, compared with the air bladder system, fewer actuating elements that you have to worry about. So just real quick, references, and then of course, we are here to get feedback on the strategies that we discussed and any suggestions you all have. Yeah.
How does strategy 2 prevent bedsores on the back of the bed?
So that is a risk of the system. It is
Sorry.
primarily related to joint actuation. Well, I don't know if I had it up there, but conceptually, these pressure ulcers form because the patient is in exactly the same state for long periods of time. Conceptually, if you're providing these macroscopic motions as part of that, they might shift around slightly as well. That's something you have to study, but yes, it is less likely to prevent those things, so it might have to be used in conjunction with some aspect of another system strategy. Yep.
So just an insight, that kind of a pressure roller is used in acupressure in India, Bangladesh, China. It might be helpful, and it's actually used for therapy. So you never know, you might have added advantage to your solution.
Yeah, this bumpy roller we've got.
Yeah, so it's used.
Yeah, it could have a
You
great
can
market.
Google and you find people actually rolling on their hands, feet, back.
Yeah, so it's a solution that's used a lot in athletics in particular.
Yeah, but it's also used for a lot of therapy before, so that's.
So you mentioned that you thought that the first strategy would have the most complicated actuators. I imagine if you had like a manifold with solenoid valves, it could be pretty simple and more straightforward than the other.
So it's not, I guess I didn't necessarily make that very clear. It's not that it would necessarily have the most complicated actuators, it's that if you have a grid of bladders you want to control, there have to be a lot of actuators. But the control of each one individually could be very
I would-
straightforward.
I would look into like big manifolds and things.
And then,
Is there any reason why they have to be individually addressable? Can you not have like sort of a grid systems where by turning on different rows and columns?
So that's the traditional system that exists, basically have
Yeah.
two states that it can take to alternate this grid pattern. The idea here being though that if it's slightly more modular, you could have additional subsystems that could be activated. So maybe you'd have 4 different configurations rather than, and however many individual bladders you have. So you could reduce the actuators with some clever subsystem design.
I guess this is sort of a similar question as the one about the second design, but for the third design with the roller underneath, is that going to be sufficient to prevent bed
So-
sores on the back?
We really don't know because most systems don't approach it from that direction, so that's something we have to look at. And as part of that, we are in contact with the Boston Home, which is a local area that has some of these kinds of patients. We're gonna go visit them and discuss whether or not they think some of these concepts would be applicable to
I
solve.
mean, the roller itself might shift the pressure, right? But it wouldn't address the joint stiffening per se, because it wouldn't like.
Yeah, I guess more so what I'm curious about is I know they shift patients traditionally from side to side to mitigate bed sore formation. And so at least from like knowing what the protocol is now, it seems like
But there's-
more motion is necessary.
There's some that do the side to side and even like lateral rotation, but there's others that just have this like, a shifting with like several, grids, parallel, so it's like.
Yeah, I'm talking about like the movement that the nurses do, is like
Oh.
flipping them from side to side. And
Yeah.
I think when it's just like the mattress pad, it's still necessary to rotate.
Yeah, so that's actually one of the goals of these more expensive systems is to have 4 parallel chambers, and by activating 2 and deactivating 2, it provides a slight rotation
Mhm.
rotation.
have you looked into like back massager chairs? You know, where you sit in a big recliner and there's the ball. like,
Yeah, so it's actually, we were discussing that at our mentor meeting just on Monday, and looking at that as a sort of analogous solution to a roller, where you can actually do something where maybe you have the roller that's also has contours on it.
Yeah, and so like especially like I know with the back massager chairs, they provide a lot of like very point and focus, like here's like poking right into like you into the lower muscles. But if you could make it so that there's a wider area of like force, then it would it would act more like a roller, and it would maybe like help shift it as opposed to like massaging.
So I think you said you wanted to keep the between $500 and $1,000. So when I look at your concepts, some of them by default are beyond.
Absolutely, yeah.
So all of them, I think the first one may be the one with the most chances to be in that price range. If you use only one actuator, one tank of the accumulator, and then as one of the students said, just use some smart valves to determine in what section. Let's say you have a matter with 8 volumes, so then you just write a code that determines what valve to open, and you send the volume.
Okay, excuse me, before we design it for us, can you go back to your list of strategies? So think about the 4th one as a hybrid.
Absolutely, yeah. So that's, I guess I didn't say that, but the idea here is these are individual concepts, but you could easily do some combination of sub-elements of them.
Yeah, and I would say these are your strategies, because as Julio was pointing out, there are a whole bunch of ways to do thematic. That's where your concepting comes in. For the hybrid, and the cost is a big risk,
Yeah.
and then the references, the back chair, how you use the bed sore thing. Physics, I think these things is the bed sore, that you understand that, but this is where the risk and the analysis cost and the power budget.
Yes.
One thing you can also think is an overlay. Pressure gets fully done. Overlay something in combo with pressure gets. Let's get you setting up so we can ask question.
Also, you can look at, actually there are a lot of solutions for backsores like water beds in developing countries and it costs less than $50. Look at that as a solution as well.
So in all these things, notice how every one of us wants to dive right in and start doing the detailed design right now, because that's the most fun. And you have to resist. Self-control, I want to talk. gotta resist, because it's too easy to get excited and go down a path. And sometimes you're lucky and you win, but very often you go down a path and it'll be in week 6 or 7. And you'll find that, oh, it's not gonna work, and I gotta start over. That's why we force you to encourage, I think you encourage on the strategy and the high level thinking and structure and layers, okay?